This last section introduces you to logarithms, and we just get a little bit of an introduction to them. If you take college algebra, you'll get a whole chapter on them, and it's an important type of function. But a logarithm is the inverse of an exponential function. So those two types of functions go together with one another. Give you kind of an idea what I mean by inverse. The function y equals x squared and the other function y equals square root of x, they are inverse functions. In other words, the square root will undo a square and squaring will undo a square root. And for example, the square root of 3 squared is 3. And if you took 3 squared and took its square root, you would still get 3. So they're sort of reversible. Well, that's what logarithms do to exponential functions, ultimately. And the reason we need that opposite action is so we can solve problems with exponential functions. If we need to solve an exponential function, we need to use logarithms. So anyway, we don't get that far with them in this course, just a little bit. But let me kind of give you the idea of logarithm here. That if we have a simple exponential function, y equals b to the x, and I like to use b for base, and x is the exponent, then we can rewrite this, solve for x. X would be the logarithm of y base b. So logarithms, and I believe it's spelled this way, L-O-G-A-R-I-T-H-M, a logarithm always has a base. And so it may be base 10, might be base 2, it might be base e, little e that we just introduced. And but logarithms have a certain base, and we take the logarithms of numbers to that base, and we get an output. So actually these two equations are equivalent. We say they're equivalent, and this is called the exponential form, and the other one is the logarithmic form. Exponential form and log, let me just call it log form for short, so I don't spend all day writing. Okay, well, it's a little hard to get excited about, and probably right yet, but logarithms were motivated by a desire to find an easier way to compute things. And it was John Napier, who was a Scotsman, in the late 1500s, early 1600s. Napier came up with logarithms, pretty much. He might not have been quite the only person looking at these, but he noticed, there might be a way to multiply by doing additions. And so we find it much easier to add things than we do to multiply. For example, when you 10 squared times 10 to the third power is 10 to the fifth power. Okay, so here's an exponent form. The rules of exponents say to when you multiply two numbers of the same base, you keep the base and you add the exponents together. So in a sense, if we're using the same base, then this multiplication is in some sense an addition of exponents. So that's the idea that propelled the creation or discovery of logarithms, that actually logarithms were used to multiply numbers together by adding their logarithms. Literally, a logarithm is an exponent. So I know this is kind of a lot to grasp in one shot, but that's the original purpose of logarithms, was to find nice ways to not only multiply but divide square numbers, take square roots of numbers, and so they're very valuable for certain computational purposes. This, of course, in the days before electronic calculators. And so anyway, that's kind of a short introduction here, and we'll go on from here.